Welcome back to the deep dive. We're here again taking some really specific, niche source material
Yeah.
and digging out those universal lessons hiding inside.
Yeah, and today it's quite the niche. We're looking at advanced outdoor pond keeping. Think series filtration, pumps, the whole setup.
Right, serious stuff. And our source, it's personal notes from a real enthusiast.
That's right, notes on fish keeping, part 62.
Mhm.
This isn't some beginner's guide, it's a log entry, actually, from November 2nd, 2024. It's all about this person, Ang, trying to really maximize efficiency in keeping the pond water super stable.
And honestly, what we found here is it's a fantastic lesson that goes way beyond fish ponds. It's kind of counterintuitive.
Totally.
Our mission today, figure out why Ang, despite all the high-tech options, ended up choosing this like laughably simple manual tool instead of automation. And the key insight really is that sometimes the best efficiency comes from giving up convenience for really precise intentional control.
Exactly. It's that point where you realize, the fancy tech is great for big jobs, but for something delicate, like a living ecosystem, sometimes you just need your own eyes and, well, a very basic tool.
Okay, so let's set the scene. What exactly was Ang trying to achieve in part 62?
All right, so Ang is focused on these outdoor ponds, and the big goal is stability, really high stability, because they're introducing some specialized fish that live right near the surface, the top level of the water.
Top level. Okay, that sounds specific. What does that matter so much?
Well, if your fish hang out near the surface, that water needs to be pristine, like almost perfect. And the biggest enemy of surface water quality, it's actually the gunk on the bottom.
The stuff on the floor.
Yeah, decaying bits, fish waste, leftover food, the substrate sludge. As that stuff breaks down, it releases ammonia, nitrates, things that mess up the whole water balance no matter how good your main filter is. It rises, essentially.
Gotcha. So Ang needed a way to clean the bottom very carefully to protect the top, not just change water volume.
Precisely. And we know this is part 62, right? So
Yeah.
they've likely tried other things before. This isn't the first attempt.
So what usually happens if you try to use like standard pond tech for this kind of bottom cleaning?
Well, the typical tools are things like powerful pumps or maybe automated substrate vacuums, designed to move a lot of water or gravel.
Right.
But they've got two big problems here. First, they're kind of like sledgehammers. They stir everything up. Huge turbulence.
Okay, so they kick up all that muck into the water you're trying to keep clean.
Exactly. You solve the bottom gunk problem by making the whole pond cloudy for a while. Not great for sensitive fish.
Right, defeats the purpose. What's the second issue?
Dilution. These big systems, they suck up everything, and the waste, sure, but also loads of perfectly clean water around it.
Huh?
So you might end up needing to drain and replace, say, 20 gallons of water just to get rid of maybe a cupful of actual concentrated waste. It's super inefficient, uses a ton of water, and, water treatment chemicals cost money too.
Okay, so Ang needed something laser-focused. Just the gunk, nothing else.
Yes. And that's what led them away from the automated timers and sensors.
And towards
What Ang describes as a remarkably long manual siphon. Basically a simple tube tool. It's the anti-tech solution.
a manual siphon. Okay, break that down. How does this thing actually work?
It's really basic physics driven by, human effort. The key part Ang mentions is this flexible bit, a small rubber section called the black bulb.
A black bulb, like those primer bulbs on small engines?
Yeah,
Or maybe a big turkey baster?
kind of like that, yeah. That bulb is the whole control mechanism. You squeeze it hard, and that creates a quick vacuum, like a negative pressure inside the long tube. Once you've got that vacuum started,
Physics takes over.
physics takes over. The water pressure pushes water up the tube, creating the siphon effect. Water flows out.
All right, I get the mechanics. Simple siphon.
But here's the thing. Ang is clearly an advanced hobbyist,
Yep.
right? Part 62. Their time must be valuable. How is squeezing a bulb over and over more efficient than just plugging in a pump and walking away? That feels backward.
That's the perfect question, and it gets right to the core of why this is interesting. The efficiency here isn't about speed. It's not about how fast you move water.
It's about
It's about the quality and the selectivity of what you remove. Those automated systems, they give you volume, but very little control over what you're sucking up.
less control, more automation.
Exactly. But this manual siphon, it gives Ang total pinpoint control.
Meaning they're not just dragging it across the whole bottom.
No. Ang can literally walk over to, say, one specific corner where some food settled, or maybe under a decorative rock. They can see a little pile of waste,
Uh-huh.
put the tube right over it, squeeze the bulb to start the siphon. No. Suck up just that concentrated little pile of gunk.
And then stop. And then stop the siphon immediately before they start pulling in lots of clean water or stirring up the sand or gravel around it.
Ah, okay, so it's targeted harvesting. Only the sludge gets taken out.
Precisely. No massive water disturbance, no cloudiness, minimal removal of clean water. The efficiency comes from focusing 100% of the effort, brief as it is, exactly where the problem is.
It's like using a tiny vacuum nozzle for crumbs on a keyboard versus trying to use a leaf blower.
That's a great analogy. One is targeted and clean, the other is powerful but makes a bigger mess. Ang noted they removed only what was needed, which kept the main body of water really stable for those top-level fish.
Okay, so the cleaning itself is way better, more precise, less disruptive, uses less water. That's already a win.
Yeah.
But you said there was more to it. The real stroke of genius happens next.
Yes. This is where it goes from just smart cleaning to, like, actual resource management. What do you do with that stuff you just siphoned out?
Right. If it was the automated system, it'd be gallons of murky water, probably just dumped.
Right. Probably, yeah, flushed down a drain or onto the lawn, maybe. You're losing those nutrients. But because Ang used the manual siphon,
They captured something different.
they captured a small amount of water that's highly concentrated with waste solids. It's not just dirty water, it's like a potent slurry of nutrients.
Okay, so it's not waste anymore.
Exactly. That's the aha moment in the notes. Ang has basically created a valuable resource on demand.
Resource, how?
Well, that concentrated fish waste sludge, it's packed with nitrogen and phosphates.
Plant food.
Bingo. Ang writes that this harvested material is used directly as fertilizer for the plant. Probably for plants around the pond, maybe in the garden.
That's brilliant. So they're taking a problem from inside the pond, excess nutrients from waste, and using it to solve a need outside the pond, feeding plants.
Yes, it's a closed loop. The single action of using this simple manual tool achieves two things: targeted cleaning inside the pond and resource harvesting for the garden outside.
One tool, two jobs, cleaning and feeding.
And Ang calls this whole process streamlined water changes. It's streamlined not because it's fast, but because it's integrated. Cleaning is resource cycling instantly.
So that choice, that sacrifice of automation for intentional manual control.
It pays off hugely. Better cleaning and free fertilizer. It demands a bit more focus in the moment, sure, but the overall ecological and resource efficiency is way higher than a more convenient automated approach for this specific task.
Okay, so let's pull back. For us, the listeners who maybe don't have a fancy pond, what's the big takeaway here?
Well, I think it's a really powerful reminder. Ang, this expert enthusiast, found that for a task needing precision and careful resource handling, a highly controllable, simple manual method was actually superior to complex automation.
We get so caught up in thinking tech means better, faster, easier.
Right. And convenience is great, but sometimes it makes us less effective. It can mask inefficiency or waste because it feels easy. This shows that trading a bit of that ease for focus control can unlock huge benefits.
Precision over broad strokes.
Which leads to maybe a final thought for you, the listener, to chew on.
Okay.
We saw Ang swap automation for manual control and immediately gain this resource recycling benefit. So think about your own life, your work. Is there some process? Maybe how you handle email or analyze data, or even just a routine chore that's currently run by some general automated system, or just a default way of doing things, something that maybe isn't as precise as it could be.
Where could swapping that broad approach for a more focused, intentional, maybe even manual method yield way better results? Where you may be throwing away potential fertilizer because the system is too blunt?
Exactly. Where could you benefit by finding your own black bulb, taking back that specific control, and maybe uncovering some hidden value?
Something to think about. Thanks for joining us for this deep dive.